We are finishing the lesson on scatter plots and lines of fit. What did I say about talking over it? All right, much better. So a lot of it we've already covered, and we're really just focusing on like the last two success criteria. So you should already know how to make a scatter plot, even though we didn't do one in the examples where we have to make it ourselves. You guys know how to plot points, right? At least I hope so, because that was in topic 2 and in this topic. But yeah, make a scatter plot by plotting points on your coordinate plane. Then you need to be able to classify the correlation as positive, negative, or no correlation. Sometimes they switch that word correlation and say association. All right, how are the variables associated with each other? Same thing. Just tell me, is it trending positive, negative, or no correlation? Then we estimated a trend line based on a scatter plot. We also learned where the trend line should be drawn. We'll practice that some more today, and how to solve for any input or output with that trend line and relate it back to those real world topics. So, couple reminders. I am recording now, so I'll post it in the slides. If you were not here yesterday, make sure you watch yesterday's lesson. Tons of good information there, but really you didn't miss a whole bunch because we're also covering the same thing today too. So we're doing a few more examples. The worksheet I will check during the exit ticket. But then again, just keep in mind, like sometimes we don't get a whole lot of time in class to work on it. Sometimes it's like 10 minutes, which is the average so far between all my classes. I've got 10 minutes in class to work on it. That's why I say on day 1 of the lesson, you get the homework, take it home and do as much as you can. You probably won't be able to do the whole thing because we haven't finished the lesson, but then at least you have some idea of where we're going, and you can ask questions accordingly because you are still taking an exit ticket at the end of class. So far, they've been good scores. So really, unless you're confused about what's going on, I expect good scores. I do also have the key to that worksheet on the back wall, but just keep in mind, I can tell, especially with this lesson, if you're just copying it. Right? Because there's no reason you should have all the same coordinates that I picked. Your answers might just be a little bit different, but they should still be close. So just make sure we're practicing, and I'll check those during the exit ticket. If I don't check yours because you're in a small group or because you didn't do it at all, then it's your responsibility to upload it. And we'll talk about assessments coming up tomorrow. Questions? All right, so then back to the notes we did yesterday. And did we get through the your turn problem? I think we just had enough time to start it. So let's see. Did we completely finish this problem? We got an answer for that one. And then we saw that it was close to this. So like if you use different points, it was so close to this. We established that. All right, so then we'll start off with, we'll actually do this one together because I have another your turn for you. So we'll start off with this one. And maybe you started, that's great. If I don't use the same points that you do, you don't necessarily have to erase it. So if you started it, that's great. Just keep it going with whatever points you have. All right, but the process should still be the same. So for this situation, we have tree height versus year after planting, so a nice little scatter plot. And the line of best fit is already drawn on there. So on your test and on your practice, you do have to draw the line yourself, but this one's drawn for you. Should the line be drawn like above the data, below the data, or the middle of the data? middle, just like how this one goes. So always like try to put it where it goes through the middle of your data and straight as possible. So use another paper if you need to, use a ruler, line it up and make as straight of a line as possible. And then you identify the 2 points. So do the 2 points have to be like the dots from the scatter plot? No, they don't have to be. They can if it aligns perfectly, like maybe a point that I would pick that looks like it aligns perfectly. Sorry, you can't see. Is this one right here. So I might pick 0, 2. If you pick a different point, that's okay. What other points did you pick? 5 and 10 works. Anyone else want to share to see if their point is to choose? 4, 8 works. All right, so 4, 8's right here. It kind of looks like the line's a little bit off-center, but 4 and 8 should still give you a good or close enough answer. What were some other ones? Earlier I heard 2, 5. All right, so there's tons of options for things that you can use. For my problem that I'm doing on the board, I'll use those 2 points. If you use different ones, just continue it with the 2 points that you did use. So once you identify your 2 points, what do you do next? Calculate your slope. So think of your end goal. All right, you want an answer that is in the form y equals mx plus b. What 2 things are normally replaced with numbers? The m and b. So we can start with the m, just like how we did in the last problem, and calculate the slope. What is the formula for that? Good. Good, so that's your slope formula. The y2 minus y1 over x2 minus x1. When you're doing slope from 2 points, use that one. So if you don't remember how to use it, I'll refresh your memory. Just label one of them as x1, y1, the other is x2, y2, and plug it in. And again, you might have labeled your points differently, but don't erase it, just see if you get the same m that I do. If I label it this way, I get 10 minus 2. Hold on, sorry. All right, I get 10 minus 2 over 5 minus 0. What's 10 minus 2? 8. And 5 minus 0? 5. Now, normally I tell you like leave the slope as a fraction, but for like comparing purposes, let's make it a decimal so we can see if you got a close answer. Do you guys know how to convert fractions to decimals? Yep, you just divide them. So in your calculator, do 8 divided by 5, get 1.6 for the m. Questions about that? I know in another class we used different points. We used 0, 2, and 2, 5, and we got m equals 1.5. I know other kids that when they did it, they got m equals 2. Still close enough, right? Any questions? All right, so in this one we got m equals 1.6. To find my b value, how can I do that? Use this formula, your slope-intercept form. We know that m equals what? 1.6. 1.6. We're solving for b, so that means I need to plug in x and y. Where can I get an x and a y from? Good, you could get it from your graph, but I say just make your life easier and use one of the points that you use to find the slope. All right, so I'll use the 0, 2, because I like the ones with zeros in them. It's usually easier to do the math. So if I use 0, 2, my y value is 2, my x value is 0, and now it's just solving for b. Questions about that? All right, what is 1.6 times 0?
0.
So I have 0 plus b equals 2. What does b equal?
2.
Did anyone notice that I didn't really have to do this? That I could have just looked at the points and saw that the y-intercept is when x is 0 and just pick that? Yeah. If you did notice it, great. If you didn't, and not always as points that you pick the y-intercept, that's how you solve for it. So then put it together in slope-intercept form. Your final answer is y equals 1.6x plus 2. Or at least something really close to that. Questions? All right, I have another you try for you, so I'm going to pass out the other paper for today. And then I'm going to have you try number 2. That will be at the top of that paper. That'll be the one that you guys do from start to finish on your own. So compare. You probably use different points than I did. What's another point that you could have used?
20 and 28.
20 and 180 also works. All right, we did it earlier in the different class, that point and the 21, 170, and we got the same exact answer. Normally it's off by just like a little bit, but we still got the same exact answer. So your final answer should be close to y equals negative 10x plus 380. It could be off by like a little bit, but if it's like way off, then there's something wrong. Questions about that? All right, so the points I used were 21, 170, and 22, 160, which I think also happen to match some of the points that were from the scatter plot. Do they have to be points from the scatter plot? No, they just happen to line up on that line really nicely, and I used those ones. But like, should I have used, and this did come up in another class, someone said that they used 25, 140. Is that a good point to use?
No.
Why?
It's not.
Because it's not on the line. And the criteria is that it has to be on the line. All right, questions about that? All right, so then you calculate your slope with that formula. You calculate your y-intercept with slope-intercept form. Where do I get the x and y from to plug in? From one of the coordinates you used. This time I used that one. Solve for b, and we got b is 380 or something close to that. Are you like confused at all at why, like the arrow, does it look like it will cross at 380? No, it kind of looks a little weird, huh? So it's because this graph, in order to make it like easier to read, they skipped a bunch of numbers. And you can tell that because of these like weird jagged lines down here. Y'all see that? All right, they skipped a bunch of numbers. Because like for the x's, it counts by ones, except for when it went from 0 to 20, right? So it skipped a bunch of numbers. But it makes sense. Like if I were to stretch out the graph and label it accordingly, it would cross at about 380. Any questions? All right, and this is like a weirder word problem. So The word problem isn't attached to it. It normally has like a story. Right now it just has a graph. And the graph is telling you the temperature and the number of gallons of maple syrup that were harvested, like from a maple syrup tree, or from a maple tree, I mean. All right, so that kind of tells you, like that's a weird example, but that'll tell you stuff and will tell you how to answer these bottom questions here. So I'm going to go back to the smart board. Because on your topic test, they're all kind of clustered together, the questions. It'll say like, what does the y-intercept represent? Or how can I solve for gallons of maple syrup at 15, 30, and 23 degrees Fahrenheit? Like it'll ask you for a specific output using your trend line. So we'll do that next. That's what these problems here are for. So the trend line that we calculated was about y equals negative 10x plus 380. So this is our linear model, right, for the data. Our data should trend this way. We're going to use our line of fit to solve for the gallons of maple syrup at 15, 30, and 23 degrees Fahrenheit. So these numbers need to be plugged into the formula. But where are they being plugged in at? What are these numbers? Are they inputs or are they outputs? Are they X's or are they Y's? And how do you know that they're X's? Good, exactly. It says it wants you to solve for the gallons of maple syrup. Gallons of maple syrup is on the y-axis. When the temperature is 15, 30, and 23 degrees. And those fall on the x-axis. All right, let me see if this is important. Hello? Hello? All right, we plugged in the x, now solve for y. And you could probably put it all in your calculator at one time. But we have negative 10 times 15 plus 380. Which gives me 230. All right, so at 15 degrees Fahrenheit, we can harvest 230 gallons of maple syrup. All right, questions there? All right, you guys try it where you're plugging in the 30. All right, so do the same thing. Solve for gallons of maple syrup when X is 30. Or when the temperature is 30. Fab. All right, good. And here's the work shown for that. I put it in function notation during that class, which is the same thing. All right, just replace the y with f of x. And we get f of 30, that's our input, equals negative 10 times 30 plus 380. Put that in our calculator, and we get 80 gallons. Questions? All right, so make sure we're trying these and not just waiting for me to put them up, because now I'm moving on to something else and you guys are like writing fast. Know that you're plugging in 30 and solving. You're gonna need to like frantically copy from the board right now. All right, but moving on. Down here, using your line of fit, what would be the temperature when there are 50, 150, and 200 gallons of maple syrup? All right, so again, here's our trend line that we estimated. This time, what are we solving for? We're solving for X. Where are those numbers being inputted? For the Y. All right, because these numbers represent gallons of maple syrup. What axis is the gallons of maple syrup on? The Y-axis. So look up here. All right, so I know that those numbers that they gave me are going to be plugged in for Y. So we'll start with the 50. When I plug in 50 for Y, this is our equation. So we're solving for the temperature, which is X. You guys should know how to solve for X, so by now. Do I get rid of the -10 first or the 380? And how do I get rid of it? Good, we're going to subtract it on each side. What's 50 minus 380? -30. Good, equal to -10x. And get the x by itself. What's opposite of multiplying by -10? So divide by -10 on each side. On the left, what's our answer? 33. 33. So it's 33 degrees Fahrenheit is the temperature when there's 50 gallons of maple syrup harvested. That make sense? All right, do the same thing that we just did, but you guys try when it's 150 gallons. Find the temperature. What's the temperature when there's 150 gallons of maple syrup? Don't get something different? Okay, so here's the work showed. So it should have been a positive 23 degrees Fahrenheit. It is possible to get negative temperatures, of course, but with this one, with the math, negative divided by negative, we get a positive. All right, questions? That makes sense? So a lot of this stuff we've already learned how to do. The big part is just making sure that we can tie it all together based on the either story problem that they're giving you or like real world problem that you might actually face. So like I mentioned this before, but like your topic for each test, all the problems are stacked together. It'll give you some data and say, describe the correlation, estimate the trend line. Use that trend line to solve for when the temperature is this. Use that trend line to solve for when there's 150 gallons of maple syrup. And then just a bunch of other stuff that we still need to learn. Questions about that? So we are going to, there's still 25 minutes of class left. We only need like the last 15 minutes to do the exit ticket. So that gives you like 10 minutes to work on your practice, which is more than some of my other classes have. So work on your practice for about 10 minutes. Again, I have the key back here for you to compare. You might not have the same exact answer that I do, but it should be close. And if you have questions or you're not sure if it's close enough, let us know and we will assist.